Hello, heat transfer is a subject in which you seamlessly move from fundamentals to applications, and it's ubiquitous in nature, from the coffee cup, from your morning coffee cup to the large process plants. Wherever there is going to be exchange of energy between two moving streams or between two surfaces, heat transfer plays a major role. And with the importance of energy and the conservation of energy that we have to consider every day while designing a process, designing a car, or designing a plant, we always have to consider this specific process where the exchange of energy is playing an important role. So, from that way, it's though its roots are in thermodynamics, but it's fundamentally different from thermodynamics because we are dealing with rates in this specific case. So, it's a very important engineering subject, not only in chemical engineering, it's also there in mechanical engineering, in biotechnology, in many of our physiological functions we exchange heat with the surroundings and so on, also in nanotechnology and several other engineering practices. So, this specific course is going to give you an introductory idea of what are the principles of heat transfer and how one can use these principles finally to design a heat exchanger. So, from the fundamental science of conduction to start with, we would aim to equip you such that you would be able to design a heat exchanger for a specific process. So, this course is going to begin with conduction, the fundamental nature of it, the one dimensional, and we will also consider multidimensional effects, the relevant laws which govern conduction, and we would see analytical as well as numerical solutions of 2D and 3D conduction problems. One of the applications of conduction is in extended surfaces, or what we call as fins, which we would find uses in many applications. So, we will talk about heat transfer from extended surfaces, how and how to design a fin, what are the characteristics of a fin, and so on. There is one more process which is important, which is the transient heat transfer process. So, most of the cases that you see when a hot object is getting cooled, the temperature is not only a function of position, it is also a function of time. So, what is the energy content? How does a surface, an object lose energy with time? Those are also important considerations for an engineer with knowledge in heat transfer. So, we will look at transient conduction problems as well. Next, we will move to convection, and in convection, we will first look at the science of convection. It is extremely important to understand how and why the convective heat transfer takes place, but it is more important that first in convection we will come across H, the heat transfer coefficient, which essentially is an engineering parameter, and most of the convection heat transfer deals with how to find this heat transfer coefficient. So, how they are related to process conditions, the velocity of the fluid which is flowing, the thermophysical properties of the fluid, the geometry of the surface, and so on. So, we will look into the evaluation of heat transfer coefficient in a variety of situations. It could be in internal flow, for example, when the flow takes place in a pipe whose surfaces are heated at a specific temperature, or a specific heat flux is provided at the surface of the tube. How would the temperature of the fluid change as we move into the tube? So, both internal and external flows, for example, in a tube or on a surface, would be discussed, and we will see what are the governing equations, how those governing equations can be reduced to using certain approximations, and how do we solve those equations to obtain, in most of the cases analytically, and in some cases we have to use semi empirical approaches to obtain a relation for H for different conditions. We are also going to look into natural convection. We will see how boiling heat transfer can be expressed in terms of parameters that we can measure, and we will also look into the condensation process. what would be the heat transfer coefficient when steam condenses on the surface, and that is going to play a very important role in designing industrial equipment. So, we will look into that as well. And next comes probably the most important part of any heat transfer course is how to design a heat exchanger. So, what are the structural components of heat transfer? What are the governing equations, the design equations for a heat exchanger? How would a heat exchanger would look like? What are the associated components that you must provide, must think of while designing a heat exchanger? So, we will confine ourselves mostly with shell and tube heat exchangers. So, what are they? How do they look like? And what are the parameters on which their efficiency would depend on? So, we will have a detailed discussion on heat exchanger equipment. The third and the last part of any heat transfer course must discuss radiation, and it is probably the strongest scientific base where we can quantify the amount of heat which is lost by any object as long as its temperature is higher than absolute zero. So, what are the laws which govern the radiation heat transfer from a surface? So, we will talk about Stefan-Boltzmann law, and we would also see that radiation is a strong function of the surface from which it is taking place. So, there are certain volumetric properties which we have to consider, but there are also some surface properties which we need to take into account. So, we will talk about reflectivity, transmittivity, emissivity and so on, and we will discuss the appropriate laws which govern the radiative heat transfer process. The another important aspect which is the application part of radiation heat transfer is how do surfaces exchange heat in an enclosure. So, there would be a network method of solving situations in which we would like to find out how much of heat is to be supplied to a specific surface in an enclosure, and how can we draw an equivalent circuit diagram of such situations, which is known as the network method. So, we will look into that as well. So, this course, heat transfer course, would give you a broad overview of the three different modes of heat transfer, their governing equations, the design equations, and most importantly how you can design a heat exchange equipment, and how you can evaluate what is using the network method, how do you find out the amount of energy exchange between surfaces at different temperatures. So, this would be an interesting application oriented with fundamental basis, and I hope that you will enjoy this heat transfer course. Thank you.